This ship weighs over 200,000 tons, and this is what stops it from drifting away. How can a chunk of metal sitting on the ocean floor hold something that massive in place? It's not just weight, it's physics. The misconception: most people think anchors work because they're heavy. Big ship, big anchor. End of story. But even large ship anchors weigh only a few dozen tons. It's huge, until you compare it to a vessel thousands of times heavier. If weight alone did the job, anchors wouldn't survive strong winds or ocean currents. So what's actually happening? Horizontal versus vertical force. The key idea is this: anchors aren't meant to resist upward force. They're designed to resist horizontal force. When a ship drops anchor, it doesn't just lower it straight down and stop. It releases a long, heavy chain. That chain stretches along the seabed. So when wind pushes the ship, the force pulls sideways, not upward. And that's exactly what the anchor is built for. The role of the chain. The chain isn't just a connector. It's part of the holding system. Because it's heavy, it forms a curved shape along the seabed. That curve absorbs force gradually. When the ship moves slightly, the chain tightens slowly before the anchor feels full tension. This prevents sudden jerks from ripping the anchor free. It also keeps the pulling angle low and flat. And that angle is everything. How the anchor digs. In modern anchors have wide flukes, flat, wing-like arms. When tension builds and the ship pulls slightly, the anchor is dragged sideways. That sideways movement forces the flukes to dig into sand or mud. The harder the ship pulls, the deeper the anchor buries itself. It's self-reinforcing. More force equals more grip. The seabed does the real work. Here's the surprising part. The anchor isn't holding the ship by itself. The seabed is. Once buried, the anchor is surrounded by compacted sediment. Sand and mud press tightly around it. Now you're not just pulling metal. You're pulling against tons of compressed earth. Friction builds rapidly. That friction is what resists the ship's movement. Surface area and friction. As the anchor digs deeper, its surface area in contact with the seabed increases. More contact means more friction. And friction is powerful. It's like trying to drag a shovel sideways once it's buried deep in wet sand. You're not lifting it. You're fighting the resistance of the ground itself. Multiply that effect by a much larger scale, and you have enough resistance to counter massive ships. Why chain length matters. Ships don't drop just a short length of chain. They release several times the depth of the water. If the water is 20 meters deep, they might release 100 meters of chain. Why? Because a flatter angle of pull forces the anchor deeper into the seabed. A steep angle would lift it out. A shallow angle strengthens it. Length equals leverage. What happens in rough weather? In strong winds or storms, the forces on the ship increase. If those forces exceed the holding power of the anchor and seabed, the anchor can begin to drag. That's why captains calculate wind speed, current strength, seabed type, chain length. Anchoring isn't guesswork. It's controlled physics. So when you see a massive ship calmly sitting in open water, it's not being held in place by weight alone. It's being held by angle, friction, force distribution, and the seabed itself. A small piece of metal doesn't stop a 200,000-ton ship. Physics does.